right, so when we first learn about electron organization, electron configurations, we draw orbital diagrams, which are the big, long, sort of everything with the boxes and the arrows. And then we shorten it up and we do electron configurations. And then we take it even further and we actually do something called noble gas configurations, which are even a more shortened form of an electron configuration. So what's important to know is that this last column of elements right here, so the column 18 or group 8A, if you look at the very top of the periodic table, those are called noble gases. Okay? And they're a group or a family, and they have the name noble gas. So what I'm going to do is I'm going to do the electron configuration for chlorine. And then I'm going to show you how to do the noble gas configuration for chlorine as well. Okay, so chlorine is 17. So let's go ahead and zoom out, and I'll use the periodic table trick. You get to see it one more time as I do the electron configuration for chlorine. Let me circle it so you can see where it is. It is number 17 on the periodic table. So we're going to work our way across. So we go 1s2, so chlorine is 1s2, and then we go to the second row, 2s2, and then we go over here to the p block, and I get 2p6, and then I have 3s2, and then I do 3p1, 2, 3, 4, 5. Okay, so that's the electron configuration for chlorine. Now what I'm going to do is I'm going to go up a row and go to the very end of the noble gas, and you see that the noble gas for chlorine is, or that's above the column, so we want to go up one. Let me just zoom in so you can see. Right here, the noble gas is neon. So neon, let me just go ahead and do the electron configuration for neon, and then you'll see where the noble gas shortcut comes from. So I'll zoom back out. Neon is number 10 on the periodic table, so neon is going to be 1s2, 2s2, 2p6. Okay? And notice that the beginning of chlorine's electron configuration right here is the same as it is for neon. So if we want to write the noble gas configuration for chlorine, what I do is I would write, chlorine down, and I'm going to go to the previous row. And so the previous row, like we said, was neon. And I'm going to write down the noble gas, and I'm going to put that symbol in brackets. And what that represents to somebody is all of neon's electron configuration. And then on top of it, we're going to add whatever is extra for chlorine. So chlorine then also has not only the same thing for that, but it has 3s2 and 3p5. All right. So let's do another example. So I'll just pull this down. Let's go ahead and try and do silver. So silver is right here. Now to do the noble gas configuration for silver, all I do is I go up a row and all the way to the end of the noble gas. And I can see, and I know it's kind of hard here, but I can see that it is krypton. All right. So let's go ahead and I can do the noble gas configuration for silver, right? I'm going to start by writing krypton in brackets. Okay, so what that says to me is all of the electrons up to krypton, and then I just need to add on what is extra. So if I just go ahead and count my rows, 1, 2, 3, 4, 5 is where silver is. So we're saying everything up to this 4p6. And then we're going to add 5s2. And then remember that the D block is behind by 1, so it's going to be 4D, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4D9. So that just creates an easy shortcut for us to express the electron configuration for something without having to write down every single electron. So we just go to the previous row, write the noble gas in brackets, and then add on whatever is required for the final row for that specific element.